2. Introduction. Secular trend or simply trend is considered as the tendency of the observations. This tendency may be linear or nonlinear in upward and downward type. There is a need to measure this component, so that one can remove the effective factors from the time series that are responsible for this. For example, increase-decrease in the price of the commodity, shares, gold due to economy boom or decline help in understand the relation between factors and also in future prediction. So that one can forecast the values of the study variable in more exact manner through modeling as well as study its characteristics. Hence our main concern in this module is to give you a brief understanding about the measure of trend and try to make it as simple as possible but informative for non-mathematical background students. In literature, there are many methods available for measurements of secular trend. Some of them are method of curve fitting by least square method and moving average method. These methods will be discussed one by one in this module along with their merits and demerits. 3. Measurement of trend. These are among the most important methods for measurements of trend. 1. Graphic method. 2. Method of semi-averages. 4. Statistical applications in environmental sciences. 3. Method of curve fitting by principle of least square. 4. Method of moving averages. We will now discuss these methods of measurement of trend in detail. 3.1. Graphical method. Graphical method, also known as freehand curve fitting, is the most simplest and flexible method for measurement trend component. This method is based on a freehand moving curve. This smooth hand curve are plotted on the values of study variable value with respect to time interval of any time series. To draw smooth hand curve, first consider study variable value on the axis and time on the x-axis. Now, plot each value of study variable against time value on the axis. After plotting, draw a curve in such a way that it presents the tendency of the original observations. Also remember that the curve should remain smooth between the values of the study variable. This freehand smooth curve eliminates the effect of other components of time series such as cyclic, seasonal, and irregular. This method can be used for all types of trend, linear and nonlinear. To obtain an appropriate trend line by using freehand curve method, one must follow some instructions. These are: I. It should be smooth. E. Sum of square of the vertical deviations of the given points of the trend must be minimum as much as possible. It can be possible when sum of the vertical deviation of the given points above trend line is equal to the sum of the vertical deviation of the given points below trend line. E. If the cycles are present in the trend line, then number of cycle must be equal to both above and below the trend line. Area of the each cycles must be almost same. Merits. A. It is simple and flexible method. B. It does not need any mathematical calculation. C. It is a time-saving method. 5. Statistical applications in environmental sciences. Demerits. A. This method is subjective. The personal bias is present in the graphical method because different type of investigator handle data in different type according to their simplicity and investigate them. So investigators get different trend line for same type of data sets. B. To use this method in a proper manner, one should be skilled and experienced who can remove this type of biasedness. This is one of the major restriction to use of this method. Example 1. Consider an example of sale of luxury cars in India. Hypothetical data, year sales. Table 1. Solution. Smooth freehand curve for sale of luxury cars in India from year 1993-1998 are shown below as Figure 1. 6. Statistical applications in environmental sciences. From the above graph, one can see that the trend line lie between the points and area of curve below the line and above the line are the same. We will now discuss the second method of measuring trend, that is method of semi-average. 3.2. Method of semi-averages. Method of semi-averages eliminates some biasedness that prevail in the graphical method. In this method, we divide whole time series into two semi-parts and take their average for obtaining trend line. For obtaining required trend line by using this method, one has to follow some steps. These are steps. First, divide the whole time series data into two equal parts with respect to time. Two parts of data can be easily obtained in case of even number of years, but in case of odd number of years, two parts can be obtained by removing the value of middle year, i.e. median. B. Now compute averages of both two parts. This average value is known as semi-averages. C. Now plot these semi-averages values against the mid-value of the respective time period covered by each part. D. Now join these 2 points and get a trend line. This is the required trend line of the given time series data. Merits. 1. It is easy to understand and apply as compared to other method of measuring trend. 2. The main advantage of this method is its objective method that is free from subjective biasedness. Hence it gives same trend values for all users. 3. This technique can be used for predicting both future and past estimates. Demerits. 1. This method assumed linear relationship that may not exist in the values of study variable. 2. The predicted values by this method are not precise and reliable, that fluctuate with a small change in the values of the study variable. 3. The use of arithmetic mean may also be questionable. 7. Statistical applications in environmental sciences. Example 2. Fit a trend line to the following car sales data by the method of semi-averages. Year sales in 1,000 units. Semi-total. Semi-average. 1993-20. First, divide cars data into two semi-parts. One is 1993-1995 and second one is 1996-1998. E. Take average of these two semi-parts, which is known as semi-average. E. Plot cars data by taking year on x-axis and sales on y-axis and line between semi-average values. Line between semi-average values are known as trend line. Figure 2. In the above graph, orange points represent the semi-averages values of car data and line between them known as a trend line. 8. Statistical applications in environmental sciences. 3.3 Method of moving average. Method of moving average method is very simple and flexible method for measuring the trend line by means of moving average of successive groups of the time series. This average process remove the fluctuation of the given time series. For finding moving average of successive group of the given time series, first one has to assume constant value m, which is known as period or extent of the moving average. Thus in the method moving average we take average of m observation at a time, i.e. we are taking moving average of m period. We start with first, second, third value and so on till all observations are covered. Thus for any time series values yt at time t where t equals 1, 2, 3, the moving average of m periods are 1 st moving average ic1 plus y2 plus ym. M. 2 nd moving average ic1 plus y2 plus ym. M so on. There are two cases according to the period of moving average. When period m is odd. If moving period m is 2k plus 1, say, where k is any integer, moving average value placed against the middle value of the corresponding time interval. For example, if m equals 7 then first moving average placed against the middle period, i.e. fourth, second moving average placed against 11th and so on. Example 3. Fit a trend line for the following data by using moving average method for odd period 5 yearly and 7 yearly. Solution. To find trend line by using moving average method for 5 yearly of 7 yearly moving average, take average of first 5 or 7 values respectively and place them third and fourth position as shown in the table respectively, so on. First 5 values MA is 131.2. Place it against third position in the third column in the table. Next take 5 values and it MA is 131.6. Place it against fourth position in the table and so on, till all values are. 9. Statistical applications in environmental sciences. Covered. First 7 values MA is 131. Places it against fourth position in the table. Next take 7 values. Its MA is 130.57. Place it against fifth position in the table and so on, till all values are covered. 10. Statistical applications in environmental sciences. B. When period m is even. If moving average period m is 2k, say, where k is any integer, moving average value placed against the intermediate value of the corresponding time interval. In this case, moving average does not coincide with a period of the given time series. For placing m a value against original value, centering technique are used. Centering is a technique in which we take average of the two moving average value and placing them in between the corresponding time periods. This corresponding moving average are known as centering moving averages. For example, if m equals 6 then first MA placed against between third and fourth time interval, second MA placed against between ninth and 10th time interval and so on. Now obtain central moving averages of two periods. These moving averages are placed against third, fourth, fifth and so on time variable values. If we use these values of moving average against given time interval then we get a trend curve. The basic problem to apply this method is to find period of moving average. Here period of moving average indicates the period of oscillatory movements in the series. So this method removes the effective cyclic effect of the series. Thus the period of moving is equal to or multiple of the period of the cyclic movements of the given series. Example 3. Fit a trend line for the following data by using of moving average method for even period 4 yearly. Solution. To find trend line by using moving average method for 4 yearly moving average, take average of first 4 values and place it between the middle of two values position as shown in the table respectively. First 4 values MA is 3.5. Place it between 1990 and 1991 in the table. Next 4 values MA is 3.75. Place it between 1991 and 1992 and so on till all the observations are covered. To place m values in front of time values, take again 2.m starting with two values 3.5 and 3.75. We get 2.ma is 3.625 that is placed against 1991 and so on. 11. Statistical applications in environmental sciences. 12. Statistical applications in environmental sciences. Merits. This method is very simple and flexible, easy to understand, does not include any typical mathematical calculation and complexity, as compared to other methods. B. This method removes all subjective characteristics. C. This method is not affected by adding a new observation in original data. D. This method is used for measurement of seasonal, cyclic and irregular fluctuations. Demerits. The main disadvantage of this method is that this method is not appropriate to provide trend value for all given time series values. B. There is no functional relationship, hence this method cannot be used for forecasting future values. C. The selection of period is not an easy task when there is no cyclic fluctuation in the time series. In this case we cannot find accurate period of moving average, cannot eliminate completely oscillatory movements from the given data. 3.4 Method of curve fitting by the principle of least squares. The principle of least square is a mathematical analysis device and most widely used method to fit a trend for a given time series. It is mostly used in cases where time series observation values relationship with time is very strong. This relationship shows the tendency of increment and decrement with an increase in the value of time. Then this method is most appropriate to get a reliable future forecast value. This method is used for all type of trends, i.e. linear and nonlinear. In this module, we will discuss the fitting of linear, exponential and logistic trends explained by principle of least squares. 1. Fitting of linear trend. Consider a straight line curve between the given time series value yt and time t given by the equation yt equals a plus bt. 1. 13. Statistical applications in environmental sciences. Principle of least square method used for finding the value of a and b by minimizing the sum of square of errors between given time series values yt and estimated value yt. Suppose E is sum of square of error yt equals a plus bt. E equals min n area summation yt minus yt2. T equals min n area summation yt minus a minus bt2. T ellipsis 2. Now differentiate equation 2 with respect to a and b, we get da. Da equals minus 2n area summation yt minus a minus bt. Da, 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 da equals where n is the number of observation i.e. time series values. After solving equation 5 and 6, one can estimate the values of a and b by putting the values of n area summation yt, n area summation tyt, and an n area summation t2 from the given data. Now after estimating the values of a and b, put these estimates of a and b in equation 1 so that one can get an estimated values of yt that can be used to fit trend line on the data. Example 4. In the following table, we have data available for the production of a crop between 1990-1995 years. We are interested in fitting the trend line on the data by using the method of curve fitting through least square. 14. Statistical application. Statistical applications in environmental sciences. B. It requires more calculations and it is not suitable for non-mathematical person to apply it to find trend values. C. The addition of even a single new observation in the given observation can change whole calculation of the method. D. It has one more disadvantage, that how to choose the type of trend curve. Trend curve may be linear, exponential, parabolic and quadratic. Thus selection of curve introduce some biasness. 4. Summary. In this module, we discussed how to measure secular trend in the data using different methods. This module has a great importance in the study of time series. In literature, there are many methods available for measurements of secular trend. Some of them are method of curve fitting by least square method and moving average method. These methods are discussed in this module along with their merits and demerits. Introduction. Measurement of time series components means to identify the components, isolate the components and eliminate the components. The components of time series like seasonal, cyclic and irregular has already been discussed in other modules. One can visit the module, Introduction to the Time Series and its Importance, to recall about the components of time series. In this module, our main concern is, if one can detect the components of time series in the data, then what to do next. One must apply some methods to measure or eliminate them. Hence in this module, measurement methods for seasonal, cyclic and irregular components are discussed one by one. In this module, first we will discuss methods of measurement for seasonal variation. As seasonal is a component of time series that prevails for a short time period, so most of measurement methods for seasonality can only be applied on the data whose values are available after a short time periods like monthly, quarterly, etc. 4. Statistical applications in environmental sciences. In